Hello everyone, my name is Jonathan Palmet, and this is my 555 project, securing restricted rooms and monitoring them remotely. As you will see, the premise of my project is that with the use of Raspberry Pi and sensors, they help small businesses keep up with securing their assets by improving their layers of security, such as physical security, strong access control measures, monitoring and testing systems, and vulnerability programs. A business can have 24/7 security monitoring of their valued assets, not only economically, but they can also monitor their systems remotely anywhere around the world. Next is my research issue description. Making two or more sensors work at the same time was my first issue, as well as making sure they were connected correctly to the Pi and breadboard. The other main issue that I had to deal with was correctly coding the system so that I can view the posted data from the triggered sensors remotely. In order to accomplish my goals, I used the following hardware. One Raspberry Pi, which cost less than $100. One breadboard and several sets of jumper cables. Female to male and male to male, which cost under $10. One HC SR501 infrared PIR motion sensor module. One buzzer alarm sensor module. One MCP3008-IP analog to digital converter, and one M393 photosensitive light sensor module. As far as the schematics on writing the sensors, I used both the Raspberry Pi GPIO layouts showing pin locations. This was found both in the Raspberry Pi book and Dr. Yoon's slides. I then applied the schematics against the wiring schematic from my vendor's website to get the correct layout or rough idea on how to wire the PIR and photosensitive sensor. For coding the sensors to the Raspberry Pi, I use code from Dr. Yoon's, code for posting data to a remote server, and code from the vendor's site. The photo displayed is the code for the motion and buzzer alarm sensors. Note that I had to update the code a bit to work with my project. Next is the code for the photosensitive light sensor and analog to digital converter. This one was a bit longer than the last one since it involved multiple pins. You will see that I edited the code to fit my project and did not need a few of the lines. Now that I got through on what was needed to accomplish my goal, we can finally move on to the actual build. First will be the PIR build with alarm buzzer sensor. I had a few issues when putting everything together that would have prevented the system from working appropriately. The first issue was dealing with the location of the PIR while it was sensing for motion. The PIR was initially overperforming and picked up movement that was close when I just wanted it to pick up motion a couple inches from its lens instead, i.e. movement of person opening, closing door. After some calibration, I reduced its sensitivity and reduced its detection. This is ideal since the hardware would need to be in a position on the restricted door where it would not pick up traffic near a monitored area. As a side note, the PIR sensor uses two slots in that are made of a unique material, making it sensitive to infrared. In the example with the dragon, the lens is not doing anything but allowing us to see that the two slots are able to look out past some distance based on the sensor's sensitivity. While idle, both the sensor's slots identify the same amount of infrared IR, such as the ambient volume emitted from its surroundings, both indoors and outdoors. Once a being that is radiating heat passes by, the sensor begins to intercept them with one half of the sensor. This triggers a positive difference in changing between both sensors. As soon as the being leaves, the sensor will revert to a negative difference. These variations in pulses is how the sensor detects. The alarm sensor was more of a secondary alert for anyone to hear if there was an intrusion into the room based on the PIR motion capture. The issue with this sensor is easily the buzzer alarm was countered. Simply covering the buzzer lightly muzzled the alarm silent so anybody close by did not hear an alarm of intrusion. I am now showing you a recording of myself showing the code used for the PIR motion detector. You notice, as I mentioned before, I had slightly modified the code to include Dr. Yoon's JSON code so we can later on retrieve the data from SciSecure.org. You are also watching a recording of the PIR motion and alarm being tested. As you can see, I have the Pi connected to not only the PIR sensor, but to an alarm as well. So when the PIR detects me, you will also hear a sharp noise to confirm detection. You will see me run the code and trip the sensor to detect intrusion. Here is a replay of the test on a clearer screen run. As you can see, the data shows that the sensor detected me and has sent the data to SciSecure with the time and date of intrusion. The second build consisted of a photosensitive light sensor, which alone had the main issue of needing to be converted from analog to digital output, which gave me more of an accurate reading of light sensitivity. Normally, a typical LDR sensor would be paired with a restrictor. This works as the resistance of a photocell reduces. The total resistance of a photocell and the pull-down resistor drops from over 600 kiloohms to 10 kiloohms, which means the current running through both resistors rises, thereby causes the voltage across the fixed 10 kiloohm resistor to rise. However, I opted to proceed with using a digital output for better reading of data by incorporating an analog to digital converter, which meant more wires and coding. I also had to adjust the sensitivity of the sensor to capture the correct amount of light to be acceptably low and high. I also included a table from one of my reference sites showing the approximate analog voltage on a sensor light/resistance with a 5-volt supply and 10 kiloohm pull-down resistor. As we approach the end of the video, we get closer to my goal. So as stated in my initial proposal, in order to rectify the issues, I continually made adjustments to the code and sensor until I received accurate data from the sensors. Once I had the information needed, I then incorporated the JSON code from Dr. Yoon's class to send the data to the class server SciSecure.org. I tested each server to confirm they were able to send data to the server as an alert of an intrusion. Given more time, I would have included a phone app to retrieve the data and receive updates on the security of the area. For now, I was able to access the information using my laptop. Similar to the previous recording, you will see me running the code for the photosensitive sensor, which was slightly adjusted to work with my project. I will also show you a recording of the sensor itself connected to the breadboard, then jump to the converter, which in turn went into the Raspberry Pi. You will notice that I turn on and off the light switch so you can see the sensor send data to SciSecure stating a high light sensitivity percentage. I ran the script again on my VNC connection so you can see the capture of data clear. For the PIR motion detection sensor, I was able to confirm it could detect intrusion by moving my hand close to the sensor. In an office setting where a room must be restricted, I would suggest placing the sensor close to the mid-bottom door jamb so it could easily detect persons and also not be noticeable. As for the buzzer, I would place the sensor in a location not easily reached in order to avoid it from being muffled silent. Next, I tested the photosensitive light sensor by going into a room with a little to no light and switching on this light switch so the sensor could detect the presence of light. Installing this in an office restricted room would be ideal since the sensor is light sensitive and can be placed in any location of the room. It would just take some adjustment to ensure an acceptable light threshold is captured. You will see that the data was successfully sent to the server for both motion and light detection. I again recorded myself refreshing the page and showing the data for the sensor showing an intrusion. To end, please note that my research plan consisted of the following. The majority of the projects were learned in class with Dr. Yoon and the various videos and slides used throughout the semester. A bit more research was done to check on the other issues that could arise using a Raspberry Pi and sensors as a deterrent for intrusion in an office setting. The main issues I have seen is the placement of the sensors. They need to remain in a constant place to continue to read accurate data. If these sensors are disturbed, it greatly reduces their ability to monitor intrusion. Other resources were used to correctly wire the sensors to the Raspberry Pi since the diagram given from the manufacturer was not entirely accurate. While I did use the origin code from the vendor, there were plenty of other coders that wrote similar code, if not easier. Based on my personal work experience, training, and literature read, it is plain to see that the use of Raspberry Pi and multiple sensors could be a great addition to a company's overall security plan, where multiple layers of protection is not only helpful but needed. Most companies, small to big, could customize their builds to fill in the gaps of the security they may have in their office. The end.